Hello everyone, and welcome to our final chapter of our 160 course. So we are going to cover chapter 8, which is on thought and language, and this is a section that wasn't originally in the first half of the course. It used to be in 161, but with the new textbook it kind of got smushed into this course. So it's not going to be that long of a chapter. I'm going to try to keep it fairly brief for you, and so then you'll have your final exam, which will be on chapter 4, the sensation and perception, as well as this chapter on the thought and language. So today we're going to start with module 1, which is the organization of knowledge. So we're going to talk a bit about kind of the basic concepts and terms and things that we talk about when we think about cognition. So some of our basic elements of cognition would be a concept, which is a mental representation of an object, event, or idea. And so a concept basically helps us to simplify and summarize information about the world, enables us to make decisions quickly. So we have what we call basic concepts, which are ones that have a moderate number of instances, and they're easier to acquire than those with few or many instances. So for example, we might consider an apple to be a more basic concept than saying fruit, which is kind of more expansive, or Macintosh, which is more specific. We might consider chair to be a more basic concept than something like an armchair, which is much more specific, or furniture, which is kind of a broader category. Children seem to be able to learn basic concepts faster than others, and adults often are shown to use them more often. So they tend to convey an optimal amount of information. And all instances within a concept share some family resemblance. Then we have categories. So categories are basically clusters of interrelated concepts. So it's important to note that within a concept you can have multiple instances, but categories are kind of even broader. They're clusters of concepts that are related to each other in some way. So the earliest approach to studying categories is referred to as rule-based categorization. So if we're trying to put something into a category, determine whether it fits the category or not, rule-based categorization would basically be that we are categorizing our objects or events according to a certain set of rules or by a specific set of features. So essentially we're considering the definition to help us categorize an item. However, rule-based categorization doesn't fully explain how we categorize some things. So for example, we have something called graded membership, which is the observation that some concepts appear to make a better category member than others. So thinking, in terms of, say, a bird, we might consider like a blue jay to be a better example of a bird than an ostrich or a penguin. And so we'll talk a little bit about why that is, why we see graded membership. So right here you can see in figure 8.1, it's kind of basically that rule-based categorization. So by using the definition of a triangle to categorize shapes, if we're looking for a triangle, we would say, well, it has to be a three-sided polygon. So in that respect, we can look at all 6 of these shapes and determine whether or not they're a triangle by using that set of rules. So that has to have it has to be a three-sided polygon. So using the definition or the criteria, the rules. And so in that case, we would have 2 of these that qualify as a triangle, and the other ones wouldn't because they don't fit that particular definition or set of rules. Whereas for table 8.1, if we were categorizing objects according to the definition of, say, bird, and we know that the definition of bird is any of the class ABs of warm-blooded, egg-laying, feathered vertebrates with 4 limbs modified to form wings. So by this definition, if we were doing it based on the rule-based characterization, we would see that both a sparrow and a penguin would obviously fit the category of birds, but if you think of bird, like I mentioned before, it is probably more of an issue of graded membership. So we'd probably be quicker to say that the sparrow fits that definition than we would to say that the penguin fits it. So exemplars and prototypes are basically things that kind of exemplify a category. You've probably heard the word exemplify before. So an exemplar is a specific example that best represents a category. So for example, when I was talking about birds, thinking of something like a blue jay or a crow, or a pigeon, maybe those would be kind of an exemplar because they very well represent that category of bird. Similar to that, a prototype is a mental representation of an average category member. So basically, it's kind of the most representative concept of a category. That was what we would call the most prototypical. And it's important to note that a prototype doesn't actually have to be a real example. It can kind of be, an image that kind of takes all of the kind of prototypical features and combines them together. So an exemplar is actually a member of a category that really well exemplifies it or best represents it, whereas a prototype is kind of taking all the kind of key features and combining them together to create an image in your mind of what that kind of exemplar would look like. So we can use prototypes as well to decide if something belongs to a category. So instead of classifying based on a rule-based definition, categorizing, I guess, we could categorize based on resemblance to a prototype or an exemplar. So the main advantage of exemplars, which would be, again, those real examples, or prototypes, which are those images combining the typical features, is that they help explain why some category members make better examples than others. So for example, in the table we just looked at, we would probably consider a sparrow to be kind of a better example because it's probably closer to our prototype for a bird. Or it probably would be considered one of kind of the exemplars of the concept of bird. Versus something like an ostrich or a penguin, it doesn't really fit the representation as well. And so therefore, we can kind of see why that graded membership might occur. So in general, when we're categorizing things, we're likely to rely on rules, that rule-based categorization, when there are complications. So when things are a little sticky and we really have to look for kind of the minor details, and resemblances when there are a few major distinctions between the items. So for example, something like a bat is pretty close in definition to what we would consider for the definition of a bird. So in that case, we'd probably have to use the rule-based categorization because there's not as big of kind of a distinction there. Like we have to look kind of for the more minor details. So in terms of prototypes, this might be an example, the kind of sketch here of a prototypical bird. It might look something like that. It combines features of actual birds such as those below. So the actual birds below, they might be considered exemplars, whereas that kind of sketch there would be considered a prototype of the concept of bird. So now we're going to talk a bit about networks and hierarchies, so in terms of our cognition. So we already talked about in the memory chapter how we tend to store things based on their relationship to each other. So we use those cognitive schemas within our brain, and so this is kind of building on that knowledge. So we know that the concepts are really important as building blocks, but they're not very useful if we can't relate them to one another in some way. So we use what are considered to be semantic networks. And those are interconnected sets of nodes or concepts, and then the links that join them to form a category. And I know that sounds kind of complicated, but I'll show you an example in a minute. So basically, our nodes are the circles that represent concepts, whereas the links connect the nodes together and represent the structure of a category, as well as the relationships among members of different categories. And so when the concepts are closer together in the network diagram, we are quicker to identify them as true. So we're more likely to say very quickly that a robin is a bird rather than a robin is an animal, just because within that semantic network, we'd see a closer relationship between robin and bird than we would robin and animal, just based on kind of the hierarchical structure. So the networks are organized in a hierarchy, which moves from very general to very specific. So I'll show you an example of what we're talking about. And so on this slide, we have a really nice representation here of a semantic network diagram for the category of animal. So for example, if you look at bird, you'll see that robin is listed under bird there. And then in between robin and animal would be the category of bird. So we'd be closer just based on how our mind organized this information. We'd be faster at saying yes if we were asked, is a robin a bird, than if we were asked, is a robin an animal. So we also have within our semantic networks something called the basic level category. And it's very similar to those basic concepts that we talked about at the beginning. So the basic level category consists of the terms that are used most often in conversation, the easiest concepts to pronounce, the prototypes, and also the level at which most thinking occurs. So for example, if you looked out in your yard and there was an animal there, you're probably likely to say, hey, there's a bird in my yard, rather than, hey, there's an animal in my yard, or hey, there's a robin in my yard, unless you're somebody who's really into bird watching and you kind of automatically, note the breed or species of the bird and you kind of say that intuitively. But most people would say, hey, there's a bird, because it's not too specific, it's not too broad. It's much more likely than saying, hey, there's an animal, or, hey, there's a whatever, crested whatever, like a specific species of a bird. And it's typically, again, like we said, kind of the easiest concept for us to pronounce. It tends to be prototypical. And yeah, we tend to kind of do most of our thinking based on kind of those basic level categories. So birds, fish, as opposed to animals, as opposed to robins and trout. And so again, it's probably easier for you to say, looking at this diagram, that a robin is a bird versus a robin is an animal. And you're probably more closely connecting a robin to having wings than you would to a robin eating, just because, again, that one's a little bit further away within the semantic network. Sorry, I apologize, my dogs are a little noisy today. So semantic networks account for priming, which again is something that we kind of discussed a bit in the memory chapter. So it's the activation of individual concepts in long-term memory. So we can measure priming through reaction time measurements or through something called a lexical decision task. So basically within the lexical decision task, volunteers are presented with a string of letters flashed on a screen, and they are quicker to determine if they spelled out a word when they were primed. So for example, if they just were given an example of, say, a fruit or an animal, and then the next word that's spelled out is another example of a fruit or an animal, then they're more likely to very quickly kind of identify that as an actual word. And so, yeah, they should be faster at identifying a word if it follows a related word, or also they've kind of demonstrated this effects if the words are, for example, what we would call in season. Sorry, I had to pause again there for a second because my dogs apparently just broke into my office. So at least they're in here now, which means they'll probably be a bit quieter. They've also done studies in which they're kind of looking at whether people are more quickly able to identify things as a word if they're kind of in season. So for example, if they conducted a study kind of in December and they use holiday words such as nutcracker or reindeer, people were faster to identify those as words when they were kind of in season versus, if they gave them those kind of words in June. So priming is kind of basically having some kind of activation of the semantic network in your mind based on whether it's a season or whether you just heard a related word, and that makes it easier for you to identify the following as a word. However, we have seen the strength of priming effects varying a great deal depending on the research, and some results have been very hard to replicate. So we do still see debates about how to best conduct further research and interpret the results. Because of course, as with anything that's implicit, so it's not something we can consciously measure, those things are always a little bit harder to kind of quantify and conduct research on. So now we'll talk briefly about categories, experience, and the brain. So we tend to categorize things based on our experience. We select categories for a concept by retrieving the items that are most similar to them from our memory. This can be an efficient process, but at times can lead us astray. So for example, there have been studies of medical students, and in diagnosing, a lot of the time they're more likely to rely on photographs than definitions. And so sometimes they might miss, for example, if somebody is suffering from a disorder, because they are basically comparing them to the prototypical kind of patient or kind of image that they've seen, rather than looking for kind of set diagnostic criteria or definitions. As well, some people have brain damage that causes them to have trouble identifying objects from certain categories, despite no problems with vision. So this is known as category-specific visual agnosia. So it seems like sometimes you could have damage to a particular area of your brain, and that is going to kind of wipe out your ability to identify objects from a specific category, which kind of leads us to believe that certain categories might be stored in kind of different areas of the brain. So we have observed differences between brain areas for categories of living and non-living things as well, which may have some kind of evolutionary adaptation. So a lot of people say that, it will be impossible for our brains to create categories for every single thing that we would encounter. And therefore, a lot of the time, it's much more likely that we're going to create specific brain areas for really important categories, such as, living animals or food sources or other people, because those would kind of help contribute to our evolutionary advantage. So here's a little example of what we were just talking about with the specific visual agnosia here, category-specific visual agnosia. So you can see that for example, this patient was really well able to identify body parts, clothing, fruit, and furniture, but pictures of animals they had a really hard time identifying. So that shows that probably that category of animal is stored somewhere else in the brain separate from these other categories, which kind of leads to that idea that certain categories have certain areas in the brain. And finally, with respect to culture and categories, how we categorize our objects depends greatly on what we have learned about these objects from our culture. So for example, the importance of plants and animals can vary from culture to culture. And one example is that objects might be categorized differently according to their culture. For example, an animal like a cow in our culture is typically considered kind of a food source, but in other cultures is actually considered to be a very sacred animal, so they would not categorize it as anything kind of to do with food. How objects relate to each other as well can also differ greatly by culture, so I'll show you an example of that on the next slide. And then Whorf, he created what was known as the linguistic relativity hypothesis. So he really thought that the language we use actually molds our thinking and our perception as well. So basically his theory said the language we use determines how we understand and categorize our world. So for example, he would say that, certain Inuit cultures, they have a lot of different words in their language to describe snow. So there might be one for blowing snow or falling snow or, wet snow. And so the fact that they have more words for the concept of snow, Whorf would say, that tells us that they actually think of snow in a different way, and they might notice features of snow that we don't notice. So basically our language can actually help guide our cognition as well. And so finally, here's a couple figures that kind of back up what we were just talking about there. So point of view, dependent on culture, we find that people from Eastern cultures, such as, East Asians, they tend to kind of focus more on the whole of the image, so kind of the background and kind of everything in relation to each other, whereas a Westerner would pick up both on the focal point and kind of the background. So you can see that in figure 8.8 based on the different areas that are active in the brain if they're looking at a picture. And then so they would be more likely to focus on the Westerner would be more likely to focus on the individual, the kind of up close picture in this figure 8.7 versus the kind of further away where you can see the background and how everything relates to each other. And then finally in B of figure 8.7 we see a cow and a chicken and some grass. And so if you ask people from certain cultures to kind of relate those together, they would probably be more likely to say, cow goes with grass because that's what the cow eats, whereas maybe in our culture we'd be likely to group cow with chicken because they're both animals. They're also both animals that we tend to eat. So you can see how things would be categorized differently and kind of thought about differently based on culture as well. So that is it for Module 1. Sorry, I kind of went through it pretty quickly, but my hope is that this will be our lecture for tomorrow, which is Wednesday, December 2nd. And then I'm really hoping that we can actually get through a good chunk of Module 2 as well. And then that way we'd be able to finish up the end of Module 2 and then Module 3 on Friday. And by next Monday, we would be ready to start reviewing for our final. So we will see what happens with the next video, but for now, I will end here and I will talk to you in the next one.